Right, in this video, I'm going to try to demonstrate what a radian is, give you a sense of what a radian is. So what I've done so far is I've taken a compass, that's this tool, and I've just drawn a circle, using that as the center, just drawn a circle, and I went ahead and drew in the x-axis there. All right, so you see how I have the arrow here? Think of this side right here as being the initial side of some angle, okay? All right, now, I took a pipe cleaner and I cut it. I cut it so it was the length of a radius, okay? So it's this length from the center to a spot on the circle, okay? Now I'm gonna slightly curve it so it follows the edge of the circle, and I'm gonna tape it down. So I'm just going to tape it so it starts right there at the initial starting spot, which would be like 0 degrees. And then I'm just going to tape it along the edge of the circle, following the curve of the circle. Okay? All right. Now, at that end, I'm going to put a little dot, and I'm going to use my straight edge to just draw the ray that goes from the center to that dot. Okay. So what I've done is I've created an angle that started right here, okay, and then it swung through that many degrees, okay. All right, now the radius of the circle and the green pipe cleaner have the same length. So this angle right here, which I'm just going to call angle A, then the measure of angle A, let me write that a little thicker. Okay. The measure of angle A winds up equaling the ratio of this length, the arc that it intercepted, and the length of that is 1 radius, divided by the radius of the circle, which is 1 radius in length, okay? And so it turns out to equal 1, and a radian is really a unitless quantity that represents the ratio between the length of the intercepted arc and, we could just say radius, but I'm going to say the length of the radius just to be clear. Okay. That would equal the measure of an angle in radians. Okay. So this particular one is 1 radian. Right now, if I go and I take another pipe cleaner that's 1 radius in length, and I pick up where I left off, and I follow the curve of the circle, 1 more radius, okay, get me to here, and I think about the end of that one, and I use my straight edge to draw the ray that goes from the center through that spot, okay. This angle, you can kind of see how it's twice the size of the other one. So you might guess this angle I'm calling angle B. Measure of angle B would equal 2 radians because it's 2 radiuses divided by 1 radius, which equals 2 radians. So see how it has intercepted an arc that's 2 radiuses in length, is the way I think about it. So it's 2 radians would be how you could represent the measure of that angle. Okay. All right, now I'm going to do one more. I take another pipe cleaner that represents 1 radius and glue it down. Doesn't quite make it all the way to the other edge, does it? And it shouldn't. Okay, so it goes about to there. Put a dot at the end of that one. Let me use a different color. Let me use green for this one. Use my straight edge to draw an angle that goes all the way from the center to that spot. Okay. And then I can call maybe this angle, angle C, right? Guess what the measure of angle C would be? Measure of angle C would be 3 radiuses. And that makes it 3 radians. Measure of angle C would be 3 radians. All right, now something else I want you to observe. See this little extra piece right here? The leftover part right there? It turns out that that little extra piece is just about 14%. It's about 0.14 of a radius. Okay. So if you had an angle, and we do have an angle that goes all the way from here, wraps all the way around to there, where the terminal side is over here, that angle, I'm going to call that angle D. The measure of angle D is about 3.14 radiuses compared to the length of the radius. And so it would be considered 3.14 radians. Well, in reality, it's exactly equal to pi radians. You remember how pi is about 3.14? Well, it turns out that if you start with the initial side of the angle way over here, and you swing it all the way around to there, that's 180 degrees, and 180 degrees is the same as pi radians. So degrees kind of focuses on the amount of the swing between the initial side and the terminal side. And radians kind of focuses on the length of the intercepted arc. Okay, but there's a relationship there. It's just how you look at it, whether you're looking at the swing, you know, how many degrees through which the terminal side swung versus how long was the arc that you cut off as compared to the radius of the circle. Okay, so a radian is just the measure of an angle that cuts off 1 radius in length. 2 radians would be the measure of an angle that cuts off 2 radiuses in length. Okay, and that's it.